All right, this is section 4.4, build quadratic models from verbal descriptions and from data. Basically what this section is, we're going to be doing word problems involving a quadratic function. Okay, so quadratic function is ax squared plus bx plus c. The graph is a parabola. Okay, we're really going to be concentrating on using the vertex formula. Okay, reason being, remember, if we're dealing with a parabola, it either opens up or down. Okay, and we know that if it opens up, it's going to have a minimum, and if it opens downward, it's going to have a maximum. So in all of these word problems, you're going to be looking for either the max or the min value, and we know for a parabola that that occurs at the vertex. So that's basically all you're going to be doing, is using your quadratic function and calculating the vertex. Okay, I know word problems can be intimidating for some people, but these are really not too bad, with the exception of number one. Number one's going to be the hardest one. Okay, but they're really not so bad because all you have to do is the vertex formula. Okay, so like I said, number one is going to be the most difficult. So we're going to start there, and then I assure you it will get easier after number one. Okay. All right. So number one, farmer in the fence problem. You can't get through algebra without doing one of these. So you have a farmer who has 4,000 meters of fencing, and he wants to enclose a rectangular plot that borders on a river. If the farmer does not fence the side along the river, what is the largest area that can be enclosed? So to start, we're going to draw a picture of what is going on. Okay, pictures really kind of help in certain situations, just to get a visual of what's going on. Okay, so we've got this farmer. He's building this rectangular plot, and it borders along the river. So I'm going to draw the river here. Okay, so here's the river. And he's not going to put fencing along this side. Okay, he's going to fence the other three sides to make his rectangular plot. Okay, and our goal is to try to figure out how the farmer should construct this enclosure so that he ends up with the maximum area possible. Okay, so what's going on here, okay, we can go ahead and draw a rectangle. Okay, and remember, this says rectangle, not square. So on a rectangle, remember, these two sides have to be the same. This side, the length of this side has to be the same as the length of this side. Okay, but in a rectangle, this side could have a different length. Okay, so I'm going to mark it with just a single little line there. Okay, so that is one way he could construct his enclosure. Okay, but again, how do we know that this is going to give us, whatever these dimensions are, how do we know that this is going to give us the maximum area? Okay, maybe he should do something long and narrow like this. Maybe he should do, so this is another way he could construct it. Okay, so maybe it should be a little longer this way. Okay, and a little shorter this way. Okay, maybe that's going to give us the maximum area. Okay, or even another possibility. Maybe we should make it more squarish. Okay, so maybe something like in between. Okay, so here's another way to construct this enclosure. Okay, so he has lots of options about how he can actually build this enclosure. Okay, the thing is, you've got to keep in mind, and it doesn't exactly say this in the problem, he is going to be using all 4,000 meters of fencing. Okay, so if we're using all 4,000 meters of fencing, you know, what should be the dimensions of each side? Okay, is it the blue thing that's going to work, or the pink construction, or the red construction? What works best? Okay, that's what we're trying to figure out. Okay, so we're going to turn this into an algebra problem. Okay, I'm going to go over here. Okay, I have all these possibilities here, but we're going to work with one possibility because we don't know which one is going to work. Okay, so let me draw this again. Okay, so let me go down here actually. All right, so again, we've got our river. Okay, And I'm just going to draw the first one I had up there. All right, so we know this side has to equal this side. Okay, and then this side could be different. Oops. All right, so it looks like this if I set it up. Okay, so this side is going to be different. All right, so if you notice, there is no function. You were not given a function in the problem. So basically, you're going to have to come up with one. And again, we need it to be quadratic. Okay. All right, so the first thing we're going to need to involve is variables. Okay. I don't know how long this side needs to be. Okay, so I'm just going to call it x. Okay, and again, since this side is x meters, this side has to be the same size, so this is also going to be x meters. Whoops. The joy of making videos at home. I keep bumping the camera. Oops. Okay, so here we go. So those two sides have to be equal. And then remember, this side doesn't necessarily have to be the same size as the other two sides. So I'm going to call this y because it could be a different length. Okay. All right. The goal of our problem, remember, we want the farmer to build this structure so that it has the largest area possible. Okay. So our goal in all of this is to maximize the area. Okay, so I'm going to call area A, okay, and we know from geometry that the area of a rectangle is base times height, so the area of this rectangle, this structure, is x times y, okay? All right, so we've kind of got an equation going. There's a couple of things about it that are problematic for us. One is that it has more than one variable. We're used to working with all x's, and this guy's got an x and a y, so we need to deal with that. And then the other thing is, this is not quadratic. I don't see anything squared, okay? We would love for our area equation to be a parabola, and since we're trying to find the maximum area, we would love it if the area equation or function were a parabola that opened downward, because then it would have a maximum, okay? So what we're going to do is try to convert this guy into a quadratic that opens downward, okay? Well, there is one piece of information that we have not used yet. We haven't incorporated the 4,000 meters of fencing, and again, I told you we're going to assume that the farmer is using all 4,000 meters, okay? So we need to use that information, okay? So what we're going to do is use that 4,000. We know that the farmer has to put X meters of fencing right here, and then Y meters of fencing along this side, and then X meters of fencing along this side. And it has to total 4,000 meters, okay? So remember, I don't know if you remember the term, all the way around, the length all the way around, that's called the perimeter, okay? So if we're calculating the perimeter of this guy, okay, we know that this side, X, plus the amount of fencing here, which is Y, plus the amount of fencing here, which is again X, has to total 4,000, okay? And so if we simplify that, we have 2 X's plus Y is equal to 4,000, okay? That's what the perimeter tells us, okay? So you're probably like, well, now I have 2 equations. How is this really working out for me? Because I still don't see anything quadratic, okay? Again, our goal is to work with the area equation and make it a quadratic that opens downward, okay? So what we're going to do is we're going to take this guy and we're going to solve it for one of the variables. I'm going to solve it for y, okay? And then we're going to substitute that result back into the area equation, okay? So watch what happens if I do this, okay? All right, so let me get some white space up here. So I'm going to come back up here, okay? So I'm going to start with my perimeter equation. 2x plus y is equal to 4,000, okay? I'm going to solve this for y, Okay, you could have solved it for x, but it's a lot easier here to solve for y. If you had actually solved it for x, you would have gotten a fraction involved, and let's not do that. Okay, it is correct, but it would be a little more difficult. Okay, so this is going to be 4,000, y is equal to 4,000 minus 2x. Okay, that's what the perimeter equation tells us. Okay, now we want to work with the area equation, which we know is x times y. I am going to substitute this value of y into the area equation. Okay, so now my area equation becomes x times y. Y is the same thing as 4,000 minus 2x. Okay, and I'm going to go ahead and simplify that. Okay, so I'm going to distribute. Okay, so I'm going to get 4,000x minus 2x squared if I distribute. Okay, and then I'm going to reorder it. I'm going to put it with descending powers of x. Okay, so just reordering here, this is going to be negative 2x squared plus, because that's a positive term, 4,000x. Okay, now my area equation is a quadratic equation. Okay, and since the a value is negative, the number in front of x squared is negative, I know that it's going to be a parabola that opens downward, and so it will have a max value. Okay, all right, so going forward, this is the equation that we're going to work with. This is not the answer yet. Okay, we're trying to figure out what the largest area that can be enclosed is. Okay, this is going to help us get there. Okay, since we know this is quadratic, it opens downward because a is negative 2. It's a negative value. And then if we identify our other variables here, b is 4,000, number in front of x, c is 0. Okay, we know since a is negative, it's a parabola that opens downward, it's going to have a maximum value, maximum area. That's what we want. Okay, so we know if we want to identify a max or a min, we want to use the vertex formula. Okay, so remember, x is negative b over 2a. Okay, so we're going to plug in our values. Okay, be careful with the signs here. That negative sign is already there. Negative 4,000 over 2 times a is negative 2. Okay, this is going to be negative 4,000 over negative 4. Okay, and so the x value that works here is 1,000. Okay, all right, so if I go back to my picture, that means this length has to be 1,000 meters. Remember, that's the units we're using here. Okay, this has to have the same length, so this is also going to be 1,000 meters. Okay, we need to calculate the value of this side. Okay, remember, we have 4,000 meters total. Okay, so these two sides add up to 2,000. So 4,000 minus 2,000, this side has to be 2,000 meters. Okay, that was pretty simple to calculate, but remember, you could have also gone back to where you solved for y, okay, and you could have said, okay, let me calculate my y. Y is 4,000 minus 2x. Okay, so that's going to be 4,000 minus 2 times 1,000. Okay, and so that would have also given you the calculation of 2,000 meters. Okay, when it's a word problem like this, it's in some kind of context and you really need to use the correct units when you're answering your question. Okay, all right, believe it or not, this is still not the answer to the question. Okay, the question asked, what is the largest area that can be enclosed? Okay, 1,000 and 2,000, those are not area numbers. They are dimensions of this enclosure. Okay, so if we want the final answer, okay, the max area, okay, we have to plug it into the area equation. We know to get the maximum area, it's x times y. Okay, so we need to do 1,000 meters times 2,000 meters. Okay, so you need to plop that into your calculator. Okay, and that's going to be a big number. Okay, that is going to give us a lot of zeros. So we're going to get two, let me see, let me count zeros. 1, 2, 3, 4, 5, 6. Okay, so it's going to be 2 million. Okay, again, you need to give me units. Okay, so the length, X was 1,000 meters and Y is 2,000 meters. Area units are, and I wrote the units here for a purpose. You're doing meters times meters, so it's going to be square meters. Okay, so that's the answer. This is the maximum area there. Okay, again, if you had been working in feet, it would have been square feet. Okay, think about, you know, your apartment or your house. It's measured in square feet. Okay, it's the same kind of thing here, meters squared or square meters. Okay, it's whatever units squared for area. Okay, and that's the end of this problem.